Hello everyone, welcome back to Ardashir. I am Jaber Fallah Ardashir, your host for today's video. Before we dive into the content, do me a favor, hit that subscribe button, turn on the notification bell, and give this video a thumbs up if you enjoy the electrifying world of first order circuit we are about to explore. We are rolling up our sleeves today to solve some examples. So let's jump right in. In this circuit, the switch is closed at time t equals 0. Obtain the equation Vc of t for t greater than or equal to 0. Okay, as you can see in this figure, this circuit is a first order circuit because it includes just the capacitor and resistors. In first order circuits, we know the capacitor voltage equation is as follows for after t equals 0. Vc of t equals Vc of infinity plus Vc of 0 plus minus Vc at infinity times e2 minus t over tau for t greater than or equals to 0. And t is related to the operation of switching. To find Vc of t, we must define and find these components, these elements, Vc of infinity, Vc of 0 plus, and also tau for this equation in this circuit. At first, we want to find Vc of 0 plus in the circuit. Since I equal C dV over dt, voltage of the capacitor cannot change instantaneously because instead of change, a voltage would be an infinite slope of voltage and that would require infinite current. So this means that right after time 0, at t equals 0 plus, the capacitor voltage must be approximately the same as the capacitor voltage at t equals 0 minus. Vc of 0 minus equals Vc of 0 plus. Therefore, in this equation, we can calculate and substitute Vc of 0 minus instead of Vc of 0 plus. We know for t less than 0, the switch is off. The switch is open, and the capacitor is open circuit. Or C, because it is connected to an infinite time to constant DC source. So we can draw the equivalent circuit in this manner. We have one 10 amps current source, 0.5 ohms resistor, and also the capacitor. And here is the Vc of t, 1 farad. And the cap also is open circuit. Okay, I remove the cap, and now we must find the Vc of t. In the circuit, in accordance with Ohm's law, the voltage of capacitor is determined by multiplying the resistance with the current from the sources, and the current source flows, all of the current source flows to this branch. and is in state this voltage is VC of 0 minus, and so VC of 0 minus equals VC of 0 plus, and this is equals to 10 times 0.5 ohm, and this is equals 5 volts. So in this equation now we found the VC of 0 plus, and now we want to determine VC as t approaches infinity, this component, and we draw the circuit at long times after the switch operation and closure. For after t equals 0, the switch is closed, and the capacitor is also open circuit. And the equivalent circuit will be as follows: 10 amperes current sources, 0.5 ohms resistor, and capacitor is open circuit, and also the switch is closed, so we have 1 over 8 ohm resistor too. The 0.5 ohm resistor and also 1 over 8 ohm resistor is in parallel in this circuit. And so the summarized circuit is here: 10 amperes with a parallel of in two resistances 1 over 10 ohm, and this voltage is VC at infinity. So VC of infinity equals 10 amperes times 1 over 10, so it is equals 1 volts. And so with this method we define the VC at infinity also. Now we want to define tau in this equation also. The time constant of a first order circuit is also determined, and for this we need to determine the R equal after t equals 0, and tau is equal for RC circuits R times C. R equal times C equal for after t equals 0. As a result, it is necessary to open the circuit for the capacitor and turn off the independent sources. In other words, the current source in this circuit is open circuit. So that the equivalent circuit will be in this form: the capacitor is turned off, so the capacitor is turned off, and also sources is off also. So the equivalent circuit is open circuit, the current source, and also we have here 0.5 ohm resistor, and also 1 over 8 ohm resistor here, and also the switch is closed. And so the R equivalent is 0.5 in parallel with 1 over 8 ohm resistor, and the equivalent of these resistors equals 1 over 10 ohm, and so tau equals 1 over 10 times 1 farad, and equals 1 over 10. Therefore, the final formula for the capacitor relationship will be as follows: VC of t equal 1 plus 5 minus 1 e to the minus 10 times t. And the simplified form, it is summarized as follows: the vc of t equals 1 plus 4 times to the e to the minus 10 times t. Thank you for watching this video. I hope this will be useful.